let's go ahead and take a look at this word problem. The function a is equal to a sub 0 times e to the power over here negative 0.0077x models what? The amount in pounds. So that's A. A is the amount in pounds of a particular radioactive material stored in a concrete vault. And X is going to be the number of years since a material was put into the vault. So they're telling you that 200 pounds of the material are initially, that's very important, initially put over here into the vault. How many pounds will be left after how many years? After 190 years. We do have a lot going on here, but let's keep track of what we have. You have an equation, and a is really a function of x if you think about it, okay? And this is a is going to be the amount. Now a of x is a sub 0 times e to the power opposite of 0.077x. And keep in mind that x is going to be over here the number of years, okay? Number of years. Now, they tell you that you have 200 pounds of the material initially. That's very important. Initially means that at x equal to 0, when you have 0 years, then you start putting some material over here. When you start, it's 200 pounds that you're putting in. So let's see where this value plugs in. Let's just look at our equation for the amount, which is a function of the time. A is the amount, remember, and then x is the time. And remember, they gave it to you as a sub 0 times e to the power over here 0.0077x. So let's plug in x is 0 years just to know basically what's going on when the time is 0. So the amount when x is 0 is going to be equal to a sub 0 times e to the power over here 0.0077, and for x, since I replace x by 0, I need to put a x here, which is also 0 for the time. So a sub 0 is equal, let me say that again, a evaluated at 0 is a sub 0 times e to the power. Let's take a look. When you multiply any number times 0 over here, what do you get? You really get 0. Okay, even if it has a negative, it's still 0. So that is e to the 0 here. So a, the amount when the time is 0, will be a sub 0 times what is e to the power 0? What is any number other than 0 raised to the 0 power? That's 1, is that right? So the amount when x is 0 is going to be a sub 0. So really a sub 0 is what we call the initial amount. And they gave you what this amount is. So a sub 0 right here is really what they gave you here. So you can plug that in. So you have the amount evaluated when we have x years. So a at x over here is going to be a sub 0. So that's 200 over here pounds times this exponential part over here. Now, they're asking you how many pounds will be left. So what is the amount when we have 190 years? So now they're telling you a time. So this is x. X is equal to 190 years. And they would like to know what is the value of a, of this function over here, a, in terms of x, when x is 190 years. So we're going to let this time x be 190, and that's in years, and plug it in. So we want to evaluate this function when x is 190 to get the amount of radioactive material that would be left. So just plug it in. Notice that x was replaced by 190. Do the same here. Replace x by 190. and let's see what we got. The amount is going to be, in this case over here, 200 times e to the power over here, whatever that is. I need to use a calculator for this one. Okay, so I was writing that, but I really need a calculator for that. So let me just scratch that out. Somebody was calling me on the phone, so sorry about that. So I need to use a little calculator to find what is E at 190. So let's go ahead and use a calculator for that. Let's see. Okay. So do me a favor, write down on a piece of paper what we have to compute. We need to compute in the calculator 200 times e to the power negative 0.077 times 190, because once I bring in the calculator, unfortunately all my writing will be gone, and that's the answer that we're looking for. Is it A, B, C, or D? Okay, so write it down again, and now let me bring in the calculator. So let's go ahead and type in what we're supposed to. We're supposed to put over here 200 times, and we want the exponential function, so do second ln to bring e to a power. Now enter the power, use a negative sign, not the subtraction, and we want 0.0077, and over here that's time over here 190, and close the parenthesis, and we get that this is, if you round it, about 46 over here for the answer, 46 pounds. Okay, so just remember it's 46 pounds. So just remember we had to compute this, and it turned out to be again 200 times e to this power over here, and that was about 46 pounds. So that tells you this is a right answer, so B is a right answer. So make sure that you can do something like that.